Okay. Hi everyone. So today's topic, which we will be talking about, is refraction of light through a plane surface. Refraction of light through a plane surface, and it is a very important chapter and quite easy one. So, you have seen it in your normal life experiences that whenever a light, you place a pencil inside a glass of water, it seems as if it's broken, right? ऐसा दिखता है हमें कि ये broken है. But that is actually not true because our eyes cannot lie and pencil is not broken, right? Pencil is not broken. You know that these are the facts, okay? So what is basically happening? Before going in the explanation why did that happen, you can identify and see there is a pattern in these four things which are in front of us. If we place a pencil inside a glass full of water, it seems to be like broken, which we have already seen. If you place a coin inside a bowl of water filled with water, it will look as if it is little bit above the ground, above the base of the bowl. Whenever you see a swimming pool, it looks shallow, whereas it is much deeper. Fourth one, in a practical application, we see fish which is not at the exact actual point where it should be when we see from a naked eye from outside. So all these things are happening and we very well know about it, that these are the things which happen in our daily life, and there is a physics behind all these things happening. And what we will learn, maybe we in this particular 10 minutes video, I will be able to cover some of it, which will be refraction, what and why, optical density of mediums, refractive index, law of refractions, glass cell and glass slabs, and lateral displacement, which we will cover later, and apparent depth and actual depth, how they are connected. After that, we will be doing some numericals and exam questions which comes in board exams. Okay, fair enough. Now we will be moving forward and covering it one by one. So the first one, what is refraction? Okay, Fritz. So basically, you can see a ray of light. So this is a ray of light which is coming over here. Okay, I have to delete this. A ray of light which is coming over here. This is your ray of light which is coming from some source. Okay, it's falling at this point and getting refracted in water. What is happening here? Basically, from air, which is medium 1, it is going into water, which is our medium 2. So the change in the direction of light when it passes from one transparent medium, which is air, to water, to another, caused by a change in its speed. So what is the reason of refraction? Can you explain this with this diagram and the definition which we have just seen? So basically, refraction is happening because of one, change in medium. Second, the most important part is basically your speed of light is changing when it travels from one medium to another. Now read the definition again. The change in the direction of light when it passes from one transparent medium to another, caused by the change in its speed. So that's the basic reason why refraction is happening. Understood? Let's move forward. Now to understand why the refraction is happening and why speed is related, how and why speed is related to refraction. Why this is happening? For example, if let us suppose you are driving a car, this is a car which you are driving on road, which is your current medium 1. Whereas you take the car at this point here, you change the medium into mud. So medium 1 was road, medium 2 is mud. So basically there is a change in the medium which impacted the speed of vehicle, your car. Correct? When you are running it on road, the speed was higher, and when you bring your car on the mud puddle, so your speed is decreased. So similarly, when an incidence ray, this ray is coming till the point that medium changed and the speed also changed. This was air, this is a denser medium, water. This is water, a denser medium. Speed in water reduces with respect to air. जैसे हमने यहां देखा, with respect to road, your speed on mud reduces. Thus, it will see a refraction, the change in the line in which light will travel. If you will see this line, if it keep traveling towards a straight line, as we know that, it travels in a light travels in a straight line format. So just wait for a second. Yeah, so ऐसा. So basically यहाँ से your light will keep traveling in this direction. Whereas we have seen that it has refracted at an angle because the change in speed, which created this angle of this. So it created a deviation. Correct? it created a deviation. Okay, so the next thing which we will understand is the speed of light. So basically the speed of light in different medias. What is medias? Again, it is same as your mediums. Which are your mediums? For example, okay, so they have so this particular place, we have vacuum, we have air, water, glass, diamond as 5 important mediums which will be discussed in this particular textbook. What is happening? The speed of light in vacuum is maximum. This is max. In air, it decreases but nearly same as vacuum for the sake of studying it. When it moves to water, with respect to air, speed reduced, right? Again, in glass, speed is further reduced. Similarly, diamond, the speed is among these 5 is the lowest one. Correct? So basically your speed, we are just talking about the speed. The speed is decreasing with these mediums. Fair enough? Understood? Vacuum, higher speed. Air, it is lesser. Water, it is lesser. Glass, it is lesser. Diamond, it is lesser. If anything, so basically vacuum speed is highest. So in any medium you will take, any medium whichever you will consider will have lower speed of light compared to vacuum. Okay. Let's move forward. Okay, the most important part, so basically what is, so there is a physical density of a product, physical density, which is mass per volume. It is not equal to optical density. We say denser medium and rarer medium. When we use these terms, these are not equal to the physical density. So basically your optical density is not equal to physical density. Okay, let's move forward now. So there are few important terms which you have to remember. So the first term is incident ray. What is incident ray? Incident ray, a ray of light which is coming from one particular source of light. This is a source of light which is giving a ray of light, and it is coming over here. That is known as incident ray, incoming light. Refracted ray. So basically ये road था, which is air, ये mud हो गया, which is water. Your medium is changing at this point of incidence. This is a point of incidence जहाँ पे everything is changing. Okay, so यहाँ पे आपका medium change हो रहा है. Now, the important part, normal, perpendicular to the surface at the point of incidence. So, which is point of incidence? Which is point of incidence? This is point of incidence. And if you make a straight line out of here, a straight line on this, which is at 90 degree, okay, the line, this angle, when we say normal, this angle is 90 degree to the surface. Surface say 90 degree. So this line, this straight line, this is called as normal. Wherever you see a normal, word normal, it means the line is at 90 degree from the surface, a perpendicular to surface at point of incidence is known as normal. Okay, and what is the next point of incidence, which we have already told you that this is the point of incidence. So सिर्फ 4 things, only 4 things. इंसिडेंट रे आ रही है, रिफ्रैक्टेड रे जा रही है, पॉइंट ऑफ इंसिडेंस हो रहा है, नॉर्मल विच इज एट 90 degree. Correct? Let's move forward. So whenever a normal, this is normal, incident ray, which is a ray of light, this is point of incident, and a normal to this, which is 90 degree, this is normal, an angle will be created. This angle is always, we will consider it only when this is calculated from the normal. The angle between the incidence ray, this ray, and the normal always measured from the normal, not the surface. Very important line. See, देखिए, what is happening? There is a surface also. This is a surface. This is one angle which is there, and from normal this angle is there. Okay, which we call as angle of incidence, angle I, which is always calculated from the normal, not from the base. यहाँ से नहीं calculate होगा, normal से ये distance calculate किया जाता है. Correct? Understood? Okay, let's move forward. What is angle of refraction? So again, there is an angle of incidence, there should be an angle of refraction, which is this angle R. Again, the same thing is applied. This is normal. This is medium 1, maybe air. Medium 2, water. At the point of incidence, this is 90 degree. This is a normal which we have created, and this is the angle which is created from the normal. Okay, so that's the case. So now there is one special case you can ask, that if a light directly enters into it, and there is no angle which is being created, so this is incident ray, this is point of incidence, this is refracted ray, and you are seeing that there is no bending across, even if in this case this is air, this is water, speed is changed, still if angle of incidence falls at 0 degree, basically सीधी लाइन आए and वो सीधी निकल जाएगी, there will be no deviation, no bending occurs, very important, no bending will occur. Okay, that is clear. So what is the first law of refraction? Okay, very good. Now we have reached to a place where we are learning the incident ray, the refracted ray, and the normal, and at the point of incidence all lie in the same plane. So this is what? This is one plane. Okay, in this plane everything is happening in this plane only. We are not going into the other planes. So everything happening at a one place, one space, this is known as the the plane. So उड़ाने वाला plane नहीं है, please remember. So this is incident ray, refracted ray, normal, 90 degree, point of incidence, medium 1, medium 2. Okay, understood? Now, what is second law of refraction? I will take this forward in next class. If you are interested to take this forward, please let me know.